welcome to the Coalcast and to what we believe is the northernmost podcast in the world. We are thrilled to have you as a listener, and we'll throughout 8 episodes give you an insight into the exciting research that goes on at the University Centre in Svalbard, or UNIS as we like to call it. You'll meet professors and students who are passionate about their coal climate research and learn more about the Arctic, both as a field of study but also as a place people call home. My name is Maria Philippa Rossi and I am your host today. For this very first episode of the Coalcast, we have the pleasure of being joined by Frank Nilsen. Frank is a professor in oceanography and has worked at UNIS since
2001.
2001, yes. You have had multiple roles here, including being in charge of the very popular Arctic geophysics course, Air, Sea and Ice Interaction. And maybe that's where we should start today, because Air, Sea, Ice Interaction is a fascinating thing. It reminds us that the universe is hitched together and that changes in one element will affect the others.
True. And thank you for having me here. I'm privileged to be part of this podcast. And yes, you're true. Air-Sea interaction, that's what Svalbard is all about, because here we meet the ocean and the atmosphere colliding together, and sometimes we have ice in between, sometimes we don't. And I think that's what we're going to discuss in this podcast.
Because in 2001, when you first moved to Longyearbyen, you experienced frozen fjords, long, cold winters. This was over 20 years ago, and 20 years is really a short time in a climate context where you need a long time series to sort of distinguish the natural variations from trends over a longer period of time. But 20 years as a researcher in Svalbard, you have it's been enough time to both see and feel the climate change?
Yes, so moving up here, or my first view over Svalbard was when I flew in 1997. And that made me fascinated about doing research up here, seeing the ice-covered fjords and the sea ice floating around Svalbard made me really interested in doing science here. So that was one of the reasons I moved up to Svalbard when the opportunity gave me a position here. And then this has then been my topic for 20 years. But during these 20 years, okay, we are using complicated instrument to kind of detect the changes that is happening in the ocean and the atmosphere. But over these 20 years, it was possible to see with your own eyes that things are changing, like sea ice disappear, glacier are retreating, temperature are being warmer in the atmosphere and the ocean. So you don't need complicated instrument to see the changes that has happened in Svalbard, which makes this study, research, and also the education feel more important.
And then something happened. A few weeks of a normal weather systems around Svalbard in the early winter of 2006 caused a new state of persistent warmer fjords. What happened?
We had started several monitoring programs, like taking measurements in the ocean and the atmosphere simultaneously. And it takes many years to understand the processes that we see. But this particular year, the processes was extreme. So just in a couple of days, all the sea ice melted without us knowing the answer to this, and didn't at that moment understand the process of how this happened. But then luckily we had started this monitoring program, so we went into the time series and looked at all the data we had, and then 1 year later we had an answer.
And what was that?
It was a combination of changing weather patterns, which is driving ocean currents. And the ocean currents around Svalbard is warm. And there was a change in current who directed all this warm water towards the coast of Svalbard and into the fjords. And the fjord was usually covered by sea ice, but at this moment, in this winter, unusual pattern in the atmosphere created unusual currents in the ocean, which melted all the ice.
The ocean is the joker when it comes to global warming. Can you explain a bit more about that?
The ocean is able to absorb 90% of all the excess heat that has come to the Earth due to global warming. And this heat is then transported northwards. And this is done through different processes. So there is a pulling process where the warm water is pulled up to the Arctic. And there is a pushing process that the wind is pushing the water northwards. But all of this is part of redistribution. So if you heat up one place, you have to distribute that to the cold place to gain balance. And this is what's happening both in the atmosphere and in the ocean. But in the climate system, I usually say that the ocean is the joker because 90%, as I said, is absorbed in the ocean. So all this excess heat is now floating around in the global circulation and on its way to the Arctic. So we can say that it's not only a global warming, but we have an ocean warming problem. So this heat is on its way to the Arctic and the Antarctic, and its effect is what we are seeing now. It's released into the atmosphere up underneath the ice and in the polar region. So it takes very long time to heat up the ocean, but when it's done, it has a potential to distribute this into the polar regions, which then influence the local climate. Because the heat capacity of the ocean is so enormous, so the 2-3 upper meter of the ocean contains the whole heat content of the atmosphere. So when you have these warm currents appearing in the Arctic, you have so much heat and energy that you are able to melt all the ice if it reaches the surface and also heat the atmosphere.
And you mentioned current, I guess most Norwegians, we heard about the Gulf Stream, which to make sure that we have nice warm summers.
Yeah.
Is it the same?
It's the same. So we have this Gulf current coming from the equator, and then it continues to flow northwards. Some of it is recirculating, meaning going back south, but a lot of warm water is transported all the way to Svalbard. And along the Norwegian coast, it's called the Norwegian Atlantic Current. And up here, it's called the Vestspitsbergen Current. But it's the same system. It's the Gulf Current system transporting its excess heat up north. So it's because we have this temperature gradient, a difference in temperature between the south and north. So you need to transport this heat northwards to compensate for this difference. So the Earth wants to be in balance, and that's why this current is alive. That's the reason we also have a much warmer climate in Svalbard and in Norway, because we have this Gulf current system. So in Svalbard, for instance, if you compare Svalbard with Greenland, on the same latitude, we have approximately 10 to 15 degrees warmer on average because of this current. If you take this current away, we're going to get as cold as Greenland. So this is the normal system. So Norway, Svalbard has always been warmer than countries on the same latitude, which doesn't have this current. But what's happening now is that this current is getting warmer. And because you're feeding more heat into the south, you also transport that to the north. And that's the reason for all the changes we see here now. So this current has become warmer. And it transports an enormous amount of heat northwards. And this is released in the Arctic region.
But then back to the winter of 2006, what happened there was a turning point for the ocean and led to this dramatic change?
Yeah. So when you heat up the Earth system, you kind of make things more chaotic, both in the ocean and the atmosphere. So you can think of a boiling pot of water. When it starts to boil, everything becomes chaotic. And that's the same when you heat the Earth system. You also change the weather patterns because there's so much energy. So low pressure systems want to go new ways because they have so much energy. That's an example. So we experienced that around Svalbard as well. And in this particular year, we noticed that the low pressure system that usually goes into the Barents Sea now started to go into Fram Strait. And if you look at the map, Spitsbergen and Svalbard is in the middle. So to the right of Svalbard, you have the Barents Sea, and to the left, you have the Greenland Sea and Fram Strait. So instead of going the usual pathways into the Barents Sea, it went straight into the Fram Strait and towards the Arctic. And with this low pressure system going towards the Arctic in the Fram Strait, you have southerly winds along the west coast of Spitsbergen. And these winds do three things. It's like a Kinder Egg effect, because you have southerly winds, which brings warm air from the south to the north. And in this particular year, you had transport of warm air from Spain to Spitsbergen. And then you, of course, push sea ice further north, so you push the sea ice away. But the long-lasting effect was the third effect, because this southerly wind started to push warm water onto the shelf towards the coast of Svalbard. So you kind of changed the ocean current, and these current transport the warm water. So all the warm water in this Gulf current system became closer to the coast of Svalbard. So you kind of flooded the shelf areas, the coastal areas of Svalbard with warm water. And as I said, the temperature of the Gulf current system had also increased. So with more heat in the current and then pushing it towards Svalbard, there was a lot of heat in front of the fjord that year. And then, okay, we couldn't actually register that when we were sitting in Longyearbyen. We saw that ice was forming, but suddenly these low pressure systems started to go in the normal directions into the Barents Sea. And then we got the northerly easterly wind back, and we got cold temperature down to -20. So we first saw that ice was growing again, but then suddenly it disappeared. It melted, but it was -20 degrees in the air. And sea ice melt and freeze when it's -1.8 degrees. So you should have expected that the sea ice was growing, but it melted and disappeared. And why was that, you wonder?
I do wonder.
And that was because the wind again opened up the fjords for this warm water. That's the easiest way to explain it. So first, the southerly wind, which was the unnormal wind situation, piled a lot of warm water up onto the shelf along the coast of Spitsbergen, the west coast. And then we turned to normal situation with easterly, northerly winds. And then we thought we were over, and now we had cold, good climate, normal climate again. No, this actually opened up the fjords and let the warm water in. So you kind of open up the doors to the fjords. And all the warm water was circulating the fjord underneath the ice. So the ice melted from below and disintegrated, even though it was -20 degrees outside.
Mm. So Longyearbyen lies on the shore of Alvefjorden, which again leads out into Isfjorden, which is the second longest fjord system in Svalbard. It's more than 100 kilometers long and 20 kilometers wide, but if you stay in town, you're sure to hear some tales about people who've driven their snowmobiles out on the fjord system and just taken it for a spin, maybe even to New Orleans and in the good old days. Have you ever experienced Isfjorden frozen?
Yes. So I was here in 98 when the fjord was frozen. So we tested that. And then after I moved here, we had one really good year of sea ice in 2004. Then I had my own dog sledge and a team of dogs. So I could start from the dog yard in Advent Valley and then drive my dogs or the dog sledge to Templefjorden, directly on the ice and into Isfjorden. So that was the last year with really good sea ice in the whole Isfjorden system. So after 2006, there hasn't been a proper ice cover of Isfjorden because this change in atmospheric circulation, that has been ongoing since this year. So everything is going a little bit slower in the ocean. So this 2 weeks of atmospheric forcing and influence from the atmosphere changed the ocean circulation and filled the fjord with warm water. But since everything takes longer time in the ocean, it takes 1 to 2 years to get rid of this heat, excess heat. But since these strange or new patterns of the low pressure system kept repeating itself for the coming years, it has been a new supply of warm water each winter nearly. So we haven't been able to revert to the normal Arctic fjord state. So we can say that the Isfjorden system and all the fjords along the west coast of Spitsbergen have been filled with Atlantic water, where it's usually Arctic water. Cold water has now been replaced by warm and salty water from the Atlantic. So we call this process an Atlantification of the Arctic fjord systems. Actually, the 2 last years, the fjord has become more like an Arctic fjord again, with colder, fresher water. The atmosphere is not cold enough to cool it down to the freezing point temperature. And this is also because, like the Barents Sea, even though we have the normal wind directions, the Barents Sea is free of ice, for example. And when you have, in the old days when the wind was blowing over these areas, it was cooled. It was not heated at least, but now we have this wind blowing over open ocean, and the ocean is warmer than the atmosphere, so it's heated on its way to Svalbard.
So it's sort of I was going to say snowball, but that may be a wrong example, but it's a snowball effect. It just gets worse and worse because it gets warmer and less ice and warmer and less ice.
True. That's what we can call a positive feedback effect. So everything is amplified. You change one bit and then that's amplifying the other, and then at the end it's a positive feedback process.
Just back to the fjord being Arctic again, how do you actually measure an Arctic or an Atlantic fjord? What do you measure?
We go out and do measurements several times during the year. And then we invite the students to join, because at UNIS we have field-based education, research-based education. So we invite all our students to join our research projects and use this opportunity to educate the students at UNIS to do fieldwork and actually to understand this process by doing their measurement themselves. So we have a data set going back 30 years where we have monitored Isfjorden and other fjords along Svalbard, but also measurements around Svalbard. So we have a pretty good data set where we can look at year-to-year changes, but also the long-term trend. So 30 years is actually enough to see these changes. And every autumn, we can kind of see what state the fjord is in, and how the development will be the coming winter. So we have at least a starting point. And the 2 last year we have seen the starting point is really good for growing sea ice, because the fjord has been losing most of its heat, and also the salinity in the fjord has been reduced. And salinity and temperature control the density of the fjord. And the density difference between the fjord and the shelf is important to describe where the warm water can flow in. Can it flow in the surface or in at the bottom? That's determined by the difference between density of the fjord and the shelf. So when you get the salinity down and the temperature down, then we are approaching a state of an Arctic fjord. And this has been going on the last 2 years. But the temperature in the atmosphere has not been as cold as usual. So therefore we were not able to grow any ice the last couple of years. But look out the window now.
I don't want to, actually.
Now we actually have another episode of what happened in 2005, 2006. So the exact same thing is happening. So we have had low pressure system now for many days and weeks, actually, going through Fram Strait. And we have transported warm air from Spain to Spitsbergen again. So we have 4 degrees outside and rain. Mm-hmm. But down in mainland Norway, they have -degrees, and somewhere they have really cold, calm weather. So all the low pressures that should have hit Bergen, my hometown, is now hitting Spitsbergen, which is the odd situation. But it's exactly the same situation we had in 2005, 2006. And look at the weather forecast. Next week, it's going to be -16 degrees. And then the wind is turning from the north again. So now for several weeks we have had warm water piling up along the coast of West Spitsbergen. And next week it will come into the fjord. So that's what we learned from our observations and measurements over 10 years ago. Mm. The same thing is happening now.
But will it then more or less sure to not have a good sea ice year?
The conditions are worsened. So the initial condition or the starting situation for the fjord has reduced the possibility for sea ice with this weather we have right now. So this is changing the current, the way we have described it. So these data set that we collect with the students has learned us to understand how this weather type will influence the ocean and the ocean currents. And this is year-to-year variability. So then we are talking about weather and the response of the ocean. But as we have discussed now, this situation has reoccurred over many years and has become the dominant pattern. And then we are talking climate, because when this happens many times enough over a long time, then you have a change of climate. So that's the difference between weather and climate. So since this is reoccurring so often, it directs warm water towards the fjord, and this water is flowing into the fjord. There is no sea ice production in winter, and it increased the temperature regionally. So now we are talking about the regional climate change.
So it's bad news, really, for everyone who wants to go skiing in Svalbard.
It is bad news, but there is still hope for snow, we hope. But the sea ice in Isfjorden is not looking very good. But luckily, we have smaller side fjords to Isfjorden. When I say Isfjorden, I'm thinking about the whole fjord system. But like Tempelfjorden and Billefjorden and these smaller fjord arms are more protected for this warm water. So you can have years where Isfjorden in the middle is ice-free, but there is okay ice in Tempelfjorden and Billefjorden. but there is not thick ice anymore, and sometimes the ice is uncertain to drive on, to be on, because it's thinner, and you can have these pulses of warm water coming into the fjord and going under the ice as well. So it's a safety issue. The ice is thinner and it's more unpredictable. It can suddenly start to melt from below as well.
Every spring you have 20 students who learn about these air sea ice interactions. How do they feel about being part of ongoing research projects?
I think they enjoy it, because that makes the course even more meaningful for them. So they come up here being enthusiastic about learning about the climate system, and they will also like to learn about the processes that are important for climate change, to understand the changes we see today. But when they hear that they are part of a bigger plan of collecting data, which is important to understand the long-term changes that we see, then they become even more enthusiastic, because each year they are part of a big puzzle. They are important bricks in this puzzle, which gives us the key to understand the changes we see. And they quickly realize that, and they are engaged in producing their own projects related to this. So we are very privileged to be able to do this kind of education and research together with the students, because we get so much energy back. And they are enthusiastic and feel that they do something important as well.
Are there any pros at all to the warmer water around Svalbard, warmer climate?
If you are a species living in the warm water, then you would like to be transported into areas with new opportunities. And one of these species are cod. And the cod is following this warm water. So for us living in Longyearbyen and around Svalbard, the only positive thing is that we can fish cod during summer and Easter. But we have lost sea ice, and we are about to lose the Arctic species if this continues. And some of my colleagues has also told me that there is a change in the bird communities already. So the birds that are depending on Arctic species is moving north, and the birds that can feed on Atlantic species are the winners, together with the Atlantic species in the ocean. So I won't say it's positive, but yes, we can fish some cods, but I would like to see the Arctic climate and the Arctic species surviving in the coming years.
You would like to go dog sledding on Eastfjorden again?
Definitely.
Yeah. All right. Well, thank you very much for the chat, Frank, and for a thorough introduction to currents and the water system around Svalbard, and not to mention the ocean's significant role in the global warming. Thank you. The Coldcast is made by technician Simen Salomonsen Hjelle and myself, Maria Philippa Rossi. Thank you very much for listening.